In this video, we are going to look at how to output the MPCs from an MSC Nastran contact analysis. So there are a few questions a viewer had, and these are the questions we're going to answer in this video. Number one, how do you output the MPCs for permanent glue? Number two, how do you turn on permanent glue? Number three, how do you display the contact status for permanent glue? And then number four, this viewer was using MSC Nastran 2017, so I'll go ahead and show you how to use that version of Nastran. Now, here's a quick look at the agenda. I'm not going to go through the agenda right now, so feel free to pause the video, and have a good look at the agenda. And now let's go ahead and get started with this exercise. If you want to follow along with this tutorial, if you want to use a pre-web app, notice that we're using a web browser to show you how to use Nastran. You can visit theengineeringlab.com. If you come here, click on the blue button in the top right hand corner. This will lead you to a form for a free trial. Fill out the form and we'll go ahead and give you access to today's web application. Now, the starting point for today's tutorial is the following. I am assuming you already have a bulk data file with the case control section with the one or more subcases. You already have your loads, your materials, your elements, your nodes. I'm assuming you are nearly complete. All there's left to do is to fine tune your contact analysis. So that's what we'll do in this video. So once you get access to the web app, you come to the home page, you click on viewer. Here, you would go ahead and click on file upload in the top left hand corner. You select the file and you upload it. After you upload the bulk data file, you'll notice that we do not have MPCs yet, and we'll get to that in a moment. Now, in the first part of the agenda, I recommend getting a copy of MSC Nastran 2017.1. Whenever you have a version of Nastran that's 5 years old or 10 years or 15 years old, you will have to go back and look at the documentation. In this case, we're looking at the quick reference guide. Throughout this video, you'll see me refer back to this document. Okay, the second item on the agenda, how do you run MSC Nastran? It's very easy. You here in the bottom left, you go to the pre panel. So again, you click this pre button. You go to the run section. Here under product version, you select 2017 or Nastran 2017. And then you would click on run, and that would run MSC Nastran 2017.0 in this case. One quick comment about the load. Let me see here. Right. So one mistake I made while preparing this exercise, let's actually run Nastran right now. Let's go ahead and first I need to add a command that will output the H5 file. So let's go ahead and add that command real quick. So create an entry, add row. So since we're using an old version of Nastran, we have to use the MDLPRM entry. So let's go ahead and use this configuration. Here on the right, you see it says MDLPRM HDF53. Okay, we're done. Let's go ahead and run this. So one mistake I did, and I want to call out this mistake so everyone is aware of it. Make sure you load your model enough so there's contact. Here, if you look at this deformation in blue, you'll notice that this plate, all the deformations for this plate here are 0. So this other plate that you see here, that's a colored rainbow, if you will. If you look at the undeformed and deformed shape, that plate is literally passing through the other plate. So why is that happening? If we look at the scale factor for the deformation, is currently 1, or it's currently 10. If we look at the scale factor at 1, you'll notice one thing. This top plate, it's not deforming enough to make contact with the other plate. So that's why the plate is all blue, all the deformation are 0. It's because the top plate is not deforming enough. If we look at the other beam, if you will, here we see that there is enough deformation that there is contact. So that was my mistake at the beginning. Number one, I was using the wrong scale factor. Whenever you look at contact analysis, the scale factor should be 1 when you look at the contact, or the deformed shape rather. So again, use the scale factor of 1. Number 2, make sure there's enough load so the contact bodies are touching each other. So here, let me quickly fix the load. So we'll go ahead and look for the force entry, and let's go ahead and up the force to 1000. So right now we're using maybe 100 newtons, and I'm increasing the value from 100 to 1000 newtons. Okay, once I do that, let's go ahead and click run. And then I think here, okay, perfect. So we'll use this for the comparison. So this is before. Again, the bottom plate has 0 deformation. And then this is what the new configuration looks like. If we look at the deformation for the bottom plate, you notice that it's no longer all blue. It's not all 0 deformation. Now it's some level of deformation. The color is now turquoise. So now we know that there's contact. And here, if you want to, you can change the scale factor to 10. This kind of helps to see if there is deformation, but again, my recommendation is use the scale factor of 1. So here, the point I'm making is use the scale factor of 1 so you do not mislead yourself. Okay, now how do we output the MPCs? So it's really easy. We'll open the go to case control, go to commands. We'll look for NLOPRM, and we'll go here and mark this checkbox. We'll go to configure. We'll look for the row with NLOPRM. We'll select MPCPCH. We'll select begin, O time, and step. And then if we look at the case control section, you notice there's a new line, NLOPRM MPCPCH begin, O time, step. We're done. Go to download, and we're running this. And remember, we're running this with MSC Nastran 2017. All of this will also work with Nastran 2025. All right, so let's go and continue. I should mention that if you want to learn more about this NLOPRM command, you will go to Nastran 2017.1 or 0 quick reference guide. Come here, you look at this table, and you look for MPC, and then this will give you a lot more information regarding what exactly that configuration does. Also, the remarks. The remarks always tell you a lot more data and information about what's going on with that command and configuration. Okay, now this is what we have. If you look at the model display panel, we get 2 new rows. MPC with the load factor of 0. So if it's 0, that's the initial contact. And then we get a second row, load factor equals 1. So this is after the load was applied. So that's the MPC configuration when the load is applied. So if we look at, let's look at the solid bodies for now. Since these solid bodies are literally touching each other, we get a lot of MPCs describing that contact. But here, since these plates are not in contact with each other, we get absent MPCs. It's not until that there's deformation when the load factor equals 1 that we finally get an MPC here at the tip. So if we look at the deformations, you can see what the MPCs look like after deformation. So we literally have contact at the tip of the top plate. The tip of the top plate is contacting the bottom plate. And then here, you can see a difference also. Before, for the initial contact, we had MPCs throughout these nodes, if you will. But after deformation, when the load factor was 1, we only get MPCs at the tip of this beam. So that's the difference between the first and the second set of MPCs. Now, when you use NLOPRM and you get the punch file that has the MPCs, that is in this table here. If you look for model.pch and download that file, let me show you what that file looks like in a text editor. So this is what that file looks like. Let's look for load factor in this file. You notice that load factor appears twice in this file. It appears in line 8 and line 516. So the change is very subtle, but remember, the first block, if you will, the first instance has a load factor of 0. These are the initial MPCs for the initial contact. And then for the next load factor, notice that it's load factor of 1. So this is after the load is applied. So we have MPCs for the initial contact and MPCs for the moment when we apply the load after the or during the deformation. So if you want to import, if you want to look at these MPCs in Patron, this is what you have to do. You take the first block of MPCs and you put those in one file, and then you take the second set of MPCs and you put those in another file. You save the files, and then for the first block of MPCs, you import those to Patron, and then when you're done, you delete those MPCs, and then you import the second file with the second set of MPCs, and then when you're done, you delete those MPCs from Patron. But here, we didn't have to do that. The pre-web app automatically did that. So now we can explore and look if the MPCs make sense or the MPCs do not make sense. So that's how you look at the MPCs. Now, there is a disclaimer here. When you go to the documentation, they will tell you a million times that the MPCs are not output for segment-to-segment contact. So here, look what happens when I turn on segment-to-segment contact. So we'll go to bulk data, select entry. We'll look for BCPARA, and we'll go ahead and turn on segment-to-segment contact. So let's go ahead and look for method, and then here for value, we'll set this to seg. Now, when we try and run this, you'll notice that Nastran will fail with an error. Here it says UFM, SFM detected in the log or F06 file. Here on the right, we get an output of the F06 file. When we look through this file, the error is going to be highlighted in red. So if we read the error in the next few lines, we see it says system fatal message MPCPCH is not supported for segment-to-segment contact. Okay, that's my mistake. I'll go back to bulk data. I'll set this to node to segment contact, and then I'll run Nastran again. And now this time, we'll be able to complete the actual analysis. Now, alternatively, you can just delete that. And when it's absent, the default is to use node to segment contact. So if it's absent, that's the same as this configuration. So if it's present or absent, it means the same thing. Okay, and now a moment ago you saw that we actually got deformations indicating it actually worked. So remember, if you use segment-to-segment contact, you are not going to get MPC entries. We did go over the model.pch file. Now, one tip when you go through this, you want to use ISEARCH equals 2. So here, if you go back to go to select entry, look for BCONPRG, or click on display selected. Here in the BCONPRG row, click that row. Here, you want to make sure that you have ISEARCH. So here, you go through the menu and you select ISEARCH, and you want to use the 2 option. So the 2 option is going to save your life when you're ever configuring contact bodies, so I recommend using it. And by the way, if you want to know why ISEARCH 2 is the better approach for this example at least, I recommend going through the MSC Nastran Nonlinear Users Guide. If you go to this chapter, Chapter 9 Contact, this would give you a lot of information regarding how contact works in MSC Nastran. Now here, if you go to this section, let me see if it's here. Okay, right. So if you go to this section, example of poor body numbering, this explains why using ISEARCH 2 might be the better approach for a lot of cases. So I figure I'd give you that tip right now. So you save some time trying to debug contact. Okay, now let me look at the questions. We looked at how to turn on the MPCs. Now let's go ahead and look at how to turn on permanent glue. So the way you do that is as follows. You just set IGLUE equal to some value. So let's go here. let's go to this entry, BCONPRG. So let me describe what BCONPRG is. So BCONPRG is handling how contact is behaving between these two contact bodies, and we have a separate BCONPRG to handle how contact is handled for these two other bodies. So if we go back here, so these are the settings for the first contact, and then these other settings are for the second contact. What you would do here to turn on glue, you click add row, you look for IGLUE, and then if IGLUE is off, you have 0 or it's blank. So that's off. If you want permanent glue, you set IGLUE to some non-zero value like 4. And now glue is on. We'll do that for the other contact. So we'll set that to IGLUE equals 4. And that's it. We're done turning on IGLUE or permanent glue. We'll go ahead and click on upload PDF and run. And now that we're done, we'll go ahead and look at the deformations. So let's go ahead and look at those deformations. Let's go ahead and turn on the coloring here. Okay, now let's go ahead and see. Okay, something really odd is happening. Am I looking at the right results? Oh, okay, so we have a little dilemma right now. One of the plates, it's deforming a lot, and it's not even detecting a contact there. Let's go ahead and see if we get some MPCs. Okay, so here there is an error we have to debug right now. If you look here, we get MPCs here, and it makes sense. The nodes are literally next to each other, but here we get no MPCs. There's no contact here. So let me look at this configuration and see if we could determine why there's no contact. Okay, let me see if it's the error. Sometimes that ends up being the error. So let's go ahead and go here. Let's use 0.4 maybe, and let's try and run this real quick. Okay, now it worked. So what happened there? Why was it not working a moment ago, and why is it working now? So this is where we talk about something called contact distance. So let me just jot down what we answered so far. So a moment ago, I showed you how to turn on glue. So that was just this. Off is when IGLUE equals 0 or IGLUE is absent. On is when it's non-zero. So I said IGLUE equal to 4, then that turned on permanent glue. Here, let me quickly answer this question. How do you display the contact status? So if you go to the post web app, if you go here to contact flexible, you mark the first checkbox. If you set this to contact status, and let me display the coloring here. Now you see that there's a contact status for these nodes and these nodes here. So that's how you answer the third question. Show you how to use Nastran 2017. And now here we went over contact status. Okay, so why was there a problem with glue? If you, or rather, let me say this. By default, Nastran calculates a distance tolerance. So if these nodes from the top plate are close enough to the bottom plate, Nastran will deem that as contact. So then it will build the MPCs and it will show you a contact status. So what was happening is Nastran generated its own contact distance, but it was not enough. Here what I did was I manually used the value of 4. Let me see if the value of 2 works. I suspect it will not work, but here, let's try it. Here, what I want to do right now is show you how to determine a good contact distance. And let's see if it worked. Okay, so that did not work. Okay, good. So you can see the plate literally passed through the other plate. That's because the contact distance that Nastran generated automatically was not enough. Also, when I tried to use my own contact distance, so here the error equals 0.2, that error was not enough. So you might be asking yourself, okay, how do I determine a good contact distance if there's no contact yet? So there are a few ways to do that. You could use something called the BCONCHK command. I don't know if that will work in this case, but okay, let me show you the practical way of determining a good distance. So one good way is you measure the distance between the nodes. So let me measure the distance between a node on the top plate and a node in the bottom plate. So you can see I've selected one node in the top and the bottom, and then we'll click on display distances. Here it tells me that the distance is 0.3. So what you can do, you can go back here and use that distance and maybe add a little offset, an offset of like 0.01, 0.5. Here I'm using an offset of a 0.01. And then when you rerun that, I expect there to be contact at that point. Now, here, let's see if there's contact now. Okay, I believe there is contact. Okay, perfect, there is contact. So before and then after deformation, notice that the top plate is now coming into contact with this other plate, and we know that because the deformations are non-zero here. Also, we get MPCs here. If you remember a moment ago, there were no MPCs, there was no contact. If you look at the model display panel, you see we do now get MPCs. So it's not literally the gap here that's being used. What's being used is the distance between the thicknesses of the top and the bottom plate. So you might be asking yourself, okay, how do we know what that distance is? So if you go to the pre and go to case control commands, you will look for this command called BCONCHK. Mark that checkbox, go to configure, look for BCONCHK here. Let's go ahead and maybe turn on plot and say run. This is not going to work for this reason. If you go back to MSC Nastran 2017 quick reference guide, that would be this document, look for BCONCHK. It's absent. It's not in this document. 8 years ago in Nastran 2017, this command did not exist. So when you try and run Nastran 2017, you get an error. Here's that error on the right. It says this: the keyword on the above card type is legal or misspelled. That's because back in 2017, BCONCHK did not exist. Here, my recommendation is upgrade to a newer version of Nastran. Here we'll use Nastran 2025.1. I think later on I'll show you where to get a newer version of Nastran. Okay, so we're running Nastran, we're done with that. And here we get the deformations, but what I want to look at now is a few things. I don't know if this will be visible in the F06 file, but hopefully it's visible here. BCONCHK. Let me make sure I did this right. There is a table that will show you. Oh, it's because I use plot. I think if I use print, then it will work. When you use BCONCHK, it's going to give you a lot more data. I think it's helpful if you look at the documentation. Let me find that example. If you look for this section called example of contact model check, when you use BCONCHK, you get a table like this, contact grid status check, and you get a plot like this, a contact distance. That's what I'm trying to show you right now. So let's go back here to the F06 file. Actually, it might be better if I download the F06 file. Sometimes these windows are too small, so it's kind of difficult to look at the data. So let me download the F06 file, and let me show you the F06 file. And then, okay, perfect. So now I get this contact grid status check. So the trick here was to use print instead of plot. So plot means just to output the data to the H5 file. Print means print the data to the F06 file and the H5 file. So print, now I have that data in the F06 file. If you look at this contact distance column, it's 0. So these would be the nodes at the top beam. So the contact distance between these nodes, they're all 0. But here, the contact distance, in this case, it would be the distance between the bottom of the thickness and the top of this thickness. What is that distance? If you look here, it'll eventually tell you that the distance is 0.245. So that you, to detect contact, you need to use an error at distance larger than that value. So here, let me show you this. Let's go to go to bulk data. Let's go back here. Let's use maybe 0.24 for the bottom plates. So error equal 0.24. Let's rerun this. When you use 0.24, you'll notice that you do not get MPCs. You do not get that initial contact. So let's go ahead and take a look at this. All right, so you can see that the plate is now going through that other plate. And then if we turn on the MPCs, we get MPCs for the top. Let me turn it off. We get MPCs for the top, but when we supplied our own contact distance, it wasn't large enough to detect contact. So now again, the distance between the bottom of the plate and the top of the plate was 2.245 meters as an example. So here what I need to do is this. I'll use 0.245 and then a small offset, and then when I rerun this, that contact distance is large enough to detect contact, in this case for permanent glue. So now I should see two things. Number one, I should see the deformation touch the other plate. So you can see there's the bottom plate is being deformed, it's being touched by the top plate, and I see MPCs. Okay, now let me look here and see what else was there to talk about for that point. Oh, right, so the contact distance. So let me recap real quick. So in the event that Nastran does not, or Nastran by default will detect its own contact distance. You notice that for the second BCONPRG, that would be for these two beams, Nastran was able to compute its own error, its own contact distance, and that was enough to detect contact. But for the bottom plates, when error was absent, when it was blank, Nastran detected or computed its own error, its own contact distance. In that original case, there were no MPCs. The gap was too big to detect contact. So what we did is we measured the distance between the bottom and top. So we measured the distance between both of these nodes. The value was 0.3. We used 0.3, and then that worked. And then we discussed that what's really happening, it's calculating the distance between the bottom and the top of the thicknesses. So it's calculating this gap. And then we saw that gap reported in the F06 file. So then we were more precise. We said, okay, use the distance calculated and then use a small offset, and then that was enough to detect contact. So that's a quick recap of what we just covered. Okay, so did we go over BCONCHK? I think we did. I know I'm going through a lot in this video, so I quickly forget if we covered it or not. Right, so we went through BCONCHK. Right, so in the guide, they actually show you a plot of the contact distance. Let me show you where that is. So when you have BCONCHK, that's going to output an additional data set called a contact grid check. So select that data set, select this checkbox, and then we get these distance values. Let's go ahead and select distance. Right, so here you can see the distance detected here is 0.245, and here there's nothing colored because the faces are hidden. Let me mark these two checkboxes to show you the faces, and let's go back to the post processor. So now you can see that there's a contact distance here. It's blue, it's 0. These nodes are 0 distance from the other nodes. Here, these nodes and these nodes are a distance of 0.2451 meters in this case, or 0.245 rather. Okay, so I showed you how to use BCONCHK. Let's talk about one thing. So remember, BCONCHK did not exist in 2017. So here we're using MSC Nastran 2025. If you're a student, you can actually get a free version of Nastran. So let's go ahead and search for that. MSC Nastran Student Edition. So here typically it's the first link. You come here, you click on Download Now. You click on Register, you fill out this form, you upload a copy of your student ID, and in less than a week, I believe you get a link to the latest version of Nastran, and it's free as long as you are a student. If you're a professional engineer, a professor, or a researcher, I believe you can contact Hexagon and get a free trial of MSC Nastran. Okay, so then if we go down the list, I did discuss the contact distance. All right, quick comment about HDF5L versus MDLPRM. So back in, I think it was 2016, they supported the H5 file. The way you output the HDF5 file is you use MDLPRM HDF5 1 or 2 or 3 or something like that. And I can't remember, in 2019 or 2020, I forget which version, they introduced a new way to output the H5 file. It's with the HDF5 out command. So let me show you how to do that in the web app. So here, if we look at if we look at selected entry, right now we're using MDLPRM HDF5 equals 3. You could use 0, 1, or 2, or 3. Let me delete this. Let me use HDF5 out. So let's go ahead and click on Reset Table, HDF5 out. Click Create Entry. Here, HDF5 is present, so if you run this, it will also work. You will get an H5 file, and then you can look at the results. So I just wanted to clarify why we use MDLPRM is because we were using MSC Nastran 2017, and then we switched to Nastran 2025, so I switched to HDF5 out. Right, so another reminder that this guide, the Nonlinear Sol 400 Users Guide, has a great chapter on contact. This will give you more information than I can share in one video. So I recommend reading this document, maybe printing it out and going through all the pages in this document. Let's see what else. Right, and another reminder, be careful with the scale factor. Here, before, I was using a scale factor of 10. Remember, use a scale factor of 1 when you look at contact results. Here, I realized that, hey, the contact body, the top plate, is passing through the bottom plate. Why was that happening? It was because when I looked at a scale factor of 1, I realized that, oh, it's because this top plate, it's not close enough to the bottom plate to detect contact. So what I had to do in this case, you could do two things. You could either increase the load factor, so increase the load, ensure that there is contact, or you increase the contact distance. But here, I think the better scenario is just increase the load. Make sure that there is contact. Use a scale factor of 1 whenever you look at your contact results. So again, use a scale factor of 1. Let me actually repeat that. And let me repeat it here a bunch of times. When you look at contact results, make sure your scale factor is 1. And here you can see I misspelled it. Okay then, so let's recap this entire video. We answered a few questions. How do you output the MPCs? So here, if you look at these MPCs, the way we output that was we went to case control commands. And here, let me scroll to the right a little. We went here, we look for NLOPRM. We marked the checkbox. We went to configure. We selected MPCPCH. We selected these 3 values, and then in the case control section, we got this new command, NLOPRM, and then we ran Nastran. We were able to see the MPCs like you see here. And then how do we turn on permanent glue? That was really simple. We went to the bulk data, select entry. We went to BCONPRG, and then we set IGLUE equals to 4. I think if it's equal to 0, glue is off. If IGLUE is absent, glue is also off. So make sure IGLUE is some non-zero value. So here, let me turn it on. Glue again and set it to 4. So now permanent glue is on. I did show you how to display the contact status, and then showed you how to use Nastran 2017.1. And now, as the last thing, just in case you do have questions on how to configure contact analysis, my email address is here, christian.aparicio@theengineeringlab.com. If you have a comment or a question, feel free to reach out, and I'll get back to you as soon as possible. So there you have it. That's how you work with contact analysis with MSC Nastran.